All right, let's do the 2008 oil slick problem, calculus free response problem. Once again, this is a calculator problem. So here we have oil leaking from a pipeline on the surface of a lake, and the oil forms a slick whose volume increases at a constant rate of 2,000 cubic centimeters per minute. So this is effectively your rate in. The oil slick takes the form of a right circular cylinder, so something that looks like this. And both its radius and its height are changing with time. Note that the volume of the right circular cylinder with radius r and height h is given by volume equals pi r squared h. First question says, at the instant when the radius is 100 centimeters and the height is half a centimeter, the radius is increasing at a rate of 2.5 centimeters per minute. At this instant, what is the rate of change of the height of the oil slick with respect to time in centimeters per minute? My friends, this is a related rates problem. So you have to start with the volume here of pi r squared h, and you're given a couple of things. You're given that the volume is increasing at 2,000 cubic centimeters per minute. So there's your dV dt. And you're being told that the radius is increasing at 2.5 centimeters per minute. So dr dt equals 2.5. And in a moment, we're going to need the fact that radius is 100 and height is 0.5. But first, we need to go ahead and differentiate implicitly here with respect to time. So dv dt is the derivative of v. And then I need the product rule here because there was no way to solve for r in terms of h or h in terms of r. Plus, they gave us two different values, one for radius and one for height. So we're going to be able to use the product rule. So let's first differentiate the r. So we bring down a 2 in front, 2 pi r h times dr dt. Don't forget your implicit differentiation on the r. Now let's differentiate h to get pi r squared, and then h just goes to dh dt. So now we're going to do some substituting. We know that at a specific time, when the oil slick, the radius is 100 centimeters, first of all, we know that dV dt is 2,000. That's all the time. But we're being given that the radius is 100 centimeters, and we're being given that the height is half a centimeter, and we know that dr dt is 2.5. So now we have pi r squared, so we have pi times, and then of course r was 1/2, and we're squaring it, and the only variable we have left is dh dt, which is exactly what we're looking for, the height of the oil slick with respect to time. So I'm going to multiply out. I have 2 times 1/2 will cancel here. And then I have 100 times 2.5 is going to be 250 pi. So my 2,000 equaled 250 pi plus, looks like 1/2 squared is 1/4, so plus pi over 4 dh dt. As I work this problem, I'm realizing that this is actually not a calculator problem, so we're going to keep on going here without a calculator. So I have now 2,000 minus 250 pi equals pi over 4 dh dt. And then I can multiply by 4 over pi on both sides. 4 over pi times 2,000 minus 250 pi is equal to dh dt. And that is all I have to put in here. Now, they asked me, let's see, they said, at this instant, what is the rate of change in centimeters per minute? So they gave us the units, which means we don't have to write the units, but just for posterity's sake, we'll say that that's in centimeters per minute. Remember, there is no reason to multiply all of this out. Just leave it exactly as it is. All right. Part B says a recovery device arrives on the scene and begins removing oil. The rate at which the oil removed is this R of t in cubic centimeters per minute, where t is the time in minutes since the device began working. Oil continues to leak at this constant rate of 2,000. So find the time when the oil slick reaches its maximum. Well, basically you have a rate in of 2,000 and a rate out of 400 rad t. So this is your candidates test problem. What you have here is an expression for rate in 2,000 minus rate out, which was 400 rad t. And these are already rates, and so if you're finding the critical points, you just set this equal to 0. So you have 2,000 equals 400 square root of t. So if I divide here, I'm going to get 2,000 divided by 400 is just 5 equals the square root of t. And now I need to square both sides of the equation, so time equals 25. So that is going to be in minutes. Now, notice that nowhere on here have they given us a domain. So we don't have a starting value for time or an ending value for time. So this is the type of problem where I only have a critical point when I'm looking for the candidates test. My only candidate is the critical point. So I just have to justify that this reaches a maximum volume. So I can do a little bit of a first derivative test here. And I'm going to do the number line just for myself. Please remember that your number line does not suffice to be backup or support on the AP exam. The reader will not read your number line. So let's plug in some value like t equals 1, shall we say. So at t equals 1, I have 2,000 minus 400 equals 0, so this is positive. And then if we choose another value like t equals 100, square root of 100 is 10. 10 times 400 is 4,000. 2,000 minus 4,000 is negative. So my rate in minus my rate out is positive where t is less than 25 and negative where t is greater than 25. And therefore, my maximum, let's make sure I word this correctly, it says find when the oil slick reaches its maximum volume. Okay, and this was going to be the volume here. Max volume at time equals 25 minutes since, and now I have to put into writing what we just did on our number line analysis. Since when t is less than 25, volume is increasing, and when t is greater than 25 minutes, volume is decreasing. So again, this number line analysis is for you. You are required to put in writing to get credit. Okay, part C says, by the time the recovery device began removing oil, 60,000 cubic centimeters of oil had already leaked. Write but do not evaluate an expression involving an integral that gives the volume of oil at the time found in part B. Okay, so what we have here for part C is that we started with 60,000, but then we need to add to that the total change. And the total change is going to be from 0 to 25. We have the rate in minus the rate out. And of course that is dt. And that will be your final answer for part C.